Okay, let's go ahead and get started today. I'm just going to quickly give some hints on how to work on your previous lab, the one with the Astro Crash game where asteroids are falling from the sky and you're supposed to shoot them with bullets. And the thing that I've been getting a few messages on where people seem to need help is with how do you get the bullets and the asteroids to collide with each other. And this isn't just true for bullets and asteroids, but any number of things that you need to do collisions in your game. So let's go ahead and get started on this. So the first thing is a quick review of Lab 7. We needed to detect when the bullets collided with falling asteroids. So we have a variable number of bullets. Obviously, it could be more than one because you can fire and the bullets can be in the air. So you could have 1, 2, 3, 5, 7, however many bullets are flying in the air at one time. And then we have a number of falling asteroids. So how do we detect those collisions between n number of bullets against m number of asteroids? So where those numbers can vary. And so what that meant was checking for a collision between each asteroid and each bullet individually. So you have to go through all asteroids and all bullets. And what we found was that a nested loop would work for that. So we go through every asteroid. So for each individual asteroid, we check it against every possible bullet. And then we go to the next asteroid, check that against every possible bullet. Go to the next one, check that against every possible bullet. Or you could do it the other way around and say for every bullet, check against every asteroid. It doesn't matter as long as we go through every asteroid checking against every bullet. So it doesn't matter which way the loops are nested. So what we came up with was something like this. So here on this picture, we've got 5 bullets, the green dots here. And here we've got 1, 2, 3, 4, 5, 6, 7 asteroids. How do we check for a collision? Well, we'd have to check every bullet against this one, every bullet against that one, every bullet against that one, and so forth through all of them. And what we came up with was this nested loop. So for every bullet in the bullet list, check it against every asteroid in the asteroid list. And like I said, it doesn't matter which order we do this, and we could switch these two lines. But right now we're going through each bullet. So for bullet 1, let's say this one here is bullet 1. So we're going to check that one against every one of the asteroids and see if it's colliding. And then if none of those are, we're going to go on to node 2. Now, one thing that might be a little confusing is the way we did this. We said if we check the distance and if it's too close, we remove both the asteroid and the bullet from the list. But this is a little bit confusing to some of you. And the reason being that looking more closely at that code there, that remove from list, that could create problems. And the reason being is that we're going through these lists. We don't really want to change those as we're going through them. In other words, removing a bullet from that bullet list while we're going through the list could cause problems. It would allow us to, like for example, I have a list of 10 things. I'm going to go through all 10, and when I get to number 7, I'm going to take it out. Well, if I take number 7 out, and then I go to the next one, what was number 8 fell into position 7, so we will have skipped over one when we went through that list for one iteration. So there's a better way to do this. So what we're going to do is rather than taking them out, we're going to mark each for removal. We're going to mark the bullet that needs to be removed, any of the bullets that need to be removed, and any of the asteroids that need to be removed. We're going to mark those in some way. And one way to do that would be to have something in the object itself that says when if it's alive or dead or needs to be removed or doesn't need to be removed. Or what I'm going to present here is a way where we make another list. And then we basically say, hey, if this one needs to be removed, add it to the bullets to be removed list. And then after that, go through that list and take any of them out that need to be taken out and take any of the asteroids out that need to be taken out. So what we're going to do is let's go ahead and write that code really quick. And I'm going to write code that's very similar to what you need to do for the lab. So, and I'm going to start from scratch with that. So if you're interested in doing that lab or already working on it, you might want to, and are struggling with that part, just focus on the one part. Otherwise, this is going to be fairly useful. So I'm going to go through this relatively quickly here. So let me get Python launched, and then I'll switch over to the screen view where you can see what I'm doing. Okay, so let me switch over so you can see what I'm doing here. Oops. Okay, so let me make this fill up the window, and then we'll go back to the other part in a second. Okay, so the first thing I'm going to do is I'm going to make a new window. me move that down to where you can see it. Let me size it so it fits on the screen a little better. Okay, that's pretty good. So this is going to be bullet asteroid collision. All right, so we're going to import Pygame, import random, import math. And what I'm going to do, or I'm going to make sure I get the window up and working. So let's do that first. So pygame.init, and then pygame.display.set mode. And I'm going to make that window 800 by 600. And that's going to create our display surface, which I'm just going to call DS here. Okay, now we are ready for our main kind of game loop here. So while true, pygame.event.pump. And that's so that incoming keystroke messages or mouse move messages or whatever that are being sent to our window, those are being processed. And then here, we want to read the keys tuple. So pygame.key.get pressed. And now if keys if they press escape, then we break out of the loop. Now at the bottom of our loop here, we're going to need to update the display. So pygame display.update. And then after the loop is done, pygame.display.quit. Now what I like to do is kind of get that. So we have this kind of framework for our program put in here, where we've initialized Pygame. We've created the window, 800 by 600. We enter a loop. The loop is going to run until we hit escape. When we hit escape, it's going to close the window down. Now what I like to do is I like to run that first. So I'm going to go and run that. I'm going to save it as bullets asteroids.py. Make sure we have the .py extension on there. And we run that. And what you'll see that we'll get is just the blank window. And then it doesn't do anything right now. I hit escape and it closes. So let's go back and add in our code. Now what I'm going to do is I know I want to have asteroids and I know I want to have bullets. So I'm going to make classes for each of those. So up here at the top, I'm going to make a class called bullet. And notice the use of a capital there. Object. And now we need to define the constructor, which has a special name. And for the constructor for the bullets, we want it to have an X and a Y position where it gets created. And for our bullets, right now we could add a speed and a size and other stuff. But for this example, I'm just going to leave that off and just have an X and a Y. When the bullet gets created at that particular spot. And in this case, the bullets are going to be pretty easy because they just go straight up the screen. We don't have to worry about them going any direction, so we don't need an angle. We don't really need a speed. We're just giving them an X and a Y, and we're going to set the speed ourselves. Now, before we do that, there is one other thing I want to do with my main loop down here. Now, I want to make sure I frame limit this. I'm going to limit it to 120 hertz. So what I'm going to do down here is I'm going to say FPS clock equal pygame.time.clock. So that creates a clock, and then inside of our loop, I'm going to do FPS clock.tick and say 120. And now we are limiting our main loop. Oops, hold on one second. Let's make sure that works. I want to make that's now limiting that. We can't tell the difference now. That's limiting that to running at 120 hertz, so 120 frames per second. Okay, so back up here to the constructor for this, self.x equal x, self.y equal y. So that's setting the attributes for that. And so there's the constructor. So down here, the next thing, self dot, let's do a draw. All right, so to draw this, we're going to do a pygame dot draw dot circle. And the circle, we're going to draw it onto the display surface. The color, I'm just going to make the bullets white, so 255, 255, 255. And the and actually, let's make them match what we had on that sheet. And I believe they were green on that thing we were just looking at. Let's make the bullets green. I think the bullets were green, the asteroids were red. Now the next thing we need is a position. So this is going to be int of self.x. int self.y. So there's the position. The radius, I'll make the radius maybe 4 for now, so we get a diameter of 8, and then we want them solid and filled in. So there's draw. Now we need a move. So this is going to move the bullets, and to move the bullets, what we want to do is the x is not going to change, but the y is. So we're going to say y minus equal. And in this case, we're going to have, as they move, minus equal. Let's just say minus equal 1. So that will, actually, let's make it 2. And at 120 hertz, that means that it's going to move about half the distance of the screen every second. We'll see what that looks like. We can always adjust that later. And if we wanted to, we could set the speed of that and do a self.speed. Set that up here and set that down here. Now, one thing that we don't have is the ability to get rid of the bullets yet. So we will take a look at how to deal with that in just a second. All right, so there's our bullet object. Now, let's go ahead and make our asteroid object, which is going to be similar. So I'm just going to copy and paste this. Except the object or the class name is going to be different. It's going to have an X, it's going to have a Y. Its draw is going to be different. I'm going to make those red instead of green. It's going to draw them at their X and Y, but they're going to be much bigger. So let's make these 20. Make them solid and filled in. And in this case, the Y is going to increase because we want them to go down the screen. So let's do Y plus equal. And instead of 2, let's make them move much more slowly. So let's just say 0.5. And we can adjust these speeds a little bit later on. Okay, so let's start out. We have our 2 classes, but we need objects to have them do something. So what I'm going to do is I'm going to make a list to keep track of each of those. So down here in my code, before I enter this, I'm going to make a bullet list. It's going to start out empty. I'm going to make an asteroid list. I'm going to start it out as empty. Now to start with, for the asteroid list, what I want to do for the asteroid list is I want to just add 10 of them to it at the beginning. And so rather than like in the game, the game description where you have to add them with this percentage chance later on, I'm just going to add 10 of them and see what it looks like. So in this case, I'm going to say for I in range 10. So it's going to go through 10 times. I'm going to say asteroid list.append to add 1 to the list. And what am I going to add? An asteroid object. And the asteroid object takes an X and a Y. So the X, I'm going to make that random. So random.rand int 0 to 799. And the Y for the asteroids, I'm going to just put it at 0 because it's at the top when it gets created. Okay, so there's my 10 asteroids. My bullet list right now is blank. I'm going to add that with a space bar here in just a little bit. But down here, I need to go through and move all the asteroids and draw all their asteroids. So for asteroid in asteroid list. So for each one in the asteroid list, I want to move it. And I want to draw it. Now, one thing that we're going to need is a clear screen before we do any moving and drawing of anything. So here to clear the screen, let's do a display surface.fill. Fill it to black. And then we move all the asteroids, draw all the asteroids, and then update the display. Now let's go ahead and run that and see what happens. And there's my 10 asteroids some of them are on top of each other, so it doesn't look quite like 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. It looks like 9, but there are 10 there. And now we also don't have anything right now that's reclaiming them when they hit the bottom of the screen. And let's make them a little bit bigger too. They look a little small, so I'm going to do... And I'm going to change this code a little bit to change this to make this the size. Let's make these 30. Let's do actually self.size equal 30. And let's put self.size here. And let's do the same thing for the bullets. So rather than hard coding this at 4, self.size, self.size equal 4. So now we can make bullets of different sizes, asteroids of different sizes. And there's my 10 asteroids falling down. And hitting the ground, and actually they keep going in this case, so they're continuing on. All right, so before I do anything else, let's make it so that they get removed from the list when they're outside of the bounds. So what I'm going to do here, this is moving them all and drawing them all, but after I move them, I'm going to decide if I want to remove any of them. So I'm going to say if asteroid.y is ever greater than, remember it was 800 by 600, so it's 600 tall. So if this is ever greater than 599, then we want to remove it from the list. But I do not want to remove it from the list right now. I don't want to say asteroid list.remove asteroid. I don't want to do that right now. And the reason being because that would be changing the list that I'm going through. So I don't want to do that. So I'm going to do something like that though. But what I'm going to do is I'm going to keep track of the ones that I need to remove. I'm going to do that by creating another list. So I'm going to say asteroids to remove list is empty. And notice I'm defining that as empty before I go through this. So I basically have an empty list right now. And once I go through all of these, any of them that I add to that list, I'm going to remove later. Asteroids to remove list.append. So I'm going to add this asteroid, any asteroid whose y coordinate is greater than 599, I'm going to add that to the to remove list. And then down here, I'm actually going to now remove them. So how do I remove them? I'm going to go through that asteroids to remove list. So for asteroid in, asteroids to remove list. Now, so I'm going to go through all the ones that are in that list that I created, and now I'm going to remove them from the asteroid list. So let's remove that asteroid from all of the ones that are in the remove list from the main asteroid list. And now what we'll see, let's run that one more time. We'll see our 10 asteroids starting at the top. And then you'll see when the center of them reaches the bottom, they all disappear. So now the list is empty. And so if we wanted them to kind of transition all the way off the screen, we could do that. But I think that what we have here shows that they're all definitely disappearing. So this is good. So this is the kind of thing we're going to do for our bullet collision stuff. So let's add in some bullets here. So what I'm going to do is I'm going to add one more class up here for a ship. So class player ship. And I'm going to give it an X and a Y position too. Its Y really isn't going to change. It's just going to move back and forth along the bottom. But what I'm going to have in here is going to be similar to what we had in the other one, self.x equal X, self.y equal Y. And let's add a draw for this guy too. And to draw that ship, what we're going to do is we're basically just going to do a triangle. But that triangle is we're going to draw that with kind of a polygon shape. So here we're going to do, well, let's come up with the 3 points. So P1x is going to be self.x. P1y is going to be self.y. P2x. Now, think of this as a triangle, and the x and y are going to be the top of that triangle. So in other words, this is the x and y. So how do I go down to the right like this, down to that other point? Well, I need to add some in x, and then I also need to add some in y. So here I'm going to say P1x is going to be let's say P2x is going to be P1x plus, and let's move over 10. So we'll make this thing 10 wide. And let's do P2y. It's going to be P1y plus, and then I'm going to make this a little bit taller, so let's make this 20. And we can change the shape of this later. And now P3 is going to be the same concept here, except P1x. Let's do minus 10 P1y plus 20. So in other words, those 2 points in the bottom are down the same amount, but one of them is over to the right and one is over to the left. All right, now we just need to draw our shape. So here, pygame.draw.polygon onto the display surface. The color of this, let's make the ship white. So 255, 255, 255. And now, if you remember how the polygon works, is it now takes a point list. So we need a list of those 3 points. So to make those 3 points, we're going to do, let's do P1x, or a list of point 1 is P1x, P1y. So that's the first point. The second point, P2x, P2y. And then the final point is P3x, P3y. So that's the end of our list. And now if you remember, how does polygon work? We now have our width. And a width of 0 will make it filled in. So let's go ahead and fill that in. So comma 0. And now that's the end of our setup for the polygon function. It's going to draw that thing on the screen. And we can change the shape of it later if we don't like how it looks. But for right now, that'll get something up there. Now, what I need here for move, I'm going to do a def move left. And that's just going to be self.x minus equal, let's do 1. And now I probably had to bound that so that it can't go off the screen. So let's say if self.x is less than 0, then self.x equals 0. All right, so that's move left. Now we're going to define a move right. And to move it right, it's going to be the same thing, but we'll do plus equal 1. And then we'll say if self.x ever gets to be greater than 799, then set it equal to 799. Okay, so down here in my code, when am I going to move that? Well, I'm going to base that on keys. So here I'm going to say if keys sub pygame dot k underscores, let's use A and D. So if they press the key A, then we're going to move the ship left. If they press D, they're going to move it right. So let me add code for both of those. Now, right now, we don't have an actual ship instance. We only have a class. So we're going to make a ship instance first. We're going to come back to that code in a second. So we need to make our ship. So up here somewhere, let's say player ship equal. Now we're going to use that class, the class we just defined up here, which is called capital player ship. And let's start it out in the middle of the screen toward the bottom. So 400. And we probably don't want to do 600 there because remember we drew it going down. So let's do 550 for right now. So that's my X and Y of where I'm creating the initial ship. And now down in my code down here, here's where I want to move it. So player ship dot move left. So again, that's calling, and actually I need to change how I named that. So move left and move right, we're calling those two methods. So the move left method, let me make sure I get the spelling right here. Move left. And then this is going to move right. So if they press A, we move left. If they press D, it moves right. And now down here, after we clear the screen and after we draw the asteroids, let's go ahead and draw the ship. So here, player ship dot draw. And let's run it and see what we get. Oop, had a typo. That needs to be keys. All right, there we go. Okay, so here it is. There are the things falling. There's my ship. It's a little triangle down there. And if I press the A, it moves left. If I press the D, it moves right, because we defined that. Now we want to make it so the spacebar shoots. Now I'm not really happy with how that ship looks. It looks a little too small to me. So I'm going to make it a little bit taller. So again, this is the advantage of this object-oriented programming. To make that taller, we can come up here. And here's where we're calculating it. So rather than plus 20, let's do plus 30 on each of those. And that looks a little better. Now, also, one other thing that we might do is like say, well, I'm not happy with all of those asteroids just being the same color. They're all just like this red color. I'd rather have them have some variation. So let's actually change it up. Let's give each of those objects or instances their own color. So up here, self.color equal. So there's the red, but let's give this a range of red values here. So let's say random.randint. Let's do 100 to 255 there. And now when we see them, we should get like a range of red shades. Oops, hold on one second. Oh, that was on the bullet. I shouldn't have done that. Well, we'll give the bullets their own potential color too. But let's, that's in the green shade. Let's do that same thing for this guy down here for the asteroid. Okay, there we go. So there it is. So now notice you can tell them apart a little bit better rather than looking like a giant blob. And if we wanted to, we could give them other shades of color, kinds of things as well. But now we have our asteroids falling down. Now, I'm going to go and take out the randomness for the bullet for right now on the color. And in fact, with the bullet, we can make it so it kind of sparkles if we wanted to. But I'm going to take this out so that they're always just a bright green. But I can still leave it with self.color, and that gives me the ability to change it later on. Okay, so now we're ready to add bullets to our bullet list. So to add bullets to the bullet list, what I'm going to do is in here, if keys, and I'm going to use the space bar to fire. So pygame.k_space. So if they press the space bar, then that means that's where I want to add a bullet to the bullet list. Bullet list.append. And here we want to add a bullet object. And the bullet object expects an X and a Y. So our X in this case is going to be where the ship's X is. So player ship.x. And the Y, let's make that where the player's Y is. So player ship.y. So that's where we're starting out the bullet when we create it. Now, we don't have a cooldown built in right now, so we're going to get a whole lot of bullets created when I do this. So here it is. Actually, I'm not getting anything. Let me take a look at why. Oh, I probably am, but I'm not rendering them. So I need to actually render those as well. So let's go through and draw all of the bullets and move all the bullets. So we need to do something similar to what we did with the asteroids here. But we need to do that for bullets. So for every bullet in our bullet list, bullet.move. And if the bullet's Y, now the bullets are moving up instead of down. So if the bullet Y ever gets to be less than 0, then we need to remove it. So we're going to make a bullets to remove list. Which means I need to make that list up here. So I'll just copy this line. And notice this copy and pasting that I'm doing. I'm just doing that to save time to make this video shorter. You could type it all out if you wanted to. Be cautious when you're doing copy and paste in programming though, because you could copy and paste something and forget to change one part of it. And then you'd have bullets being added to the asteroid list or something wrong happening. Now, we've marked bullets to be removed. Now we need to go through and clean those out as well. So let's just do the same copy paste here. Change this to bullet. Bullet. In bullets to remove list. And then we're going to go through and remove all of the ones that have been tagged for removal from the bullet list. All right, let's run that and see what we get. So there we are. There are the bullets being fired. And notice it's, here, let me move while I'm doing that. Notice that we don't have a cooldown period, so we're getting a whole lot of them. So I can kind of make like a laser thing going on here. Vertical geometry dash thing going on here. All right, anyway, notice that is working. Now, we don't have the bullet. Let's add a cooldown for that gun, for the cannon. Now, how do I add it? Did I add a cooldown before? Well, let's go ahead and do that. Now, one way we can do that is by adding that cooldown variable. So I'm going to go and do that and say gun here. Let's call it let's call it gun cooldown equal 0. So there's my cooldown variable. And what I'm going to do is every time through the loop that I press the spacebar and I append a bullet, I'm going to set gun cooldown equal. I'm going to set that equal to some value. So in this case, we're at 120 frames a second. Let's say we want to fire every quarter second, so let's set that to 30. Now, what I'm going to do here is I'm only going to let it append a bullet to the list if the cooldown is at 0. So here, I'm going to say if gun cooldown is equal to 0, then I allow this to happen, and I set the cooldown equal to 30. Now, outside of the if statement, I'm going to say if the gun cooldown is greater than 0, then subtract 1 from it. Okay, and this is a kind of a common thing. We could actually do this with times if we wanted to, but we're just doing it with frames since we have a constant frame rate. We know 30 is a quarter of a second worth of frames. So for every time through the main loop, we're saying, hey, if the gun cooldown is greater than 0, it's not all the way cooled down yet. Cool it down one amount. So essentially when we fire the gun, it sets that to 30, and then it starts counting down 30, 29, 28, 27, all the way till it gets down to 0. Once it's down to 0, it can fire again. And let's run that and look at the effect that had. Oops, I need a double equal there. There we go. So now notice we don't get that giant stream of them like we had before. We're going to get exactly 4 per second. Now notice we still don't have our bullet and asteroid collision working yet. So let's add that in. And then that will be all we're going to do today. So right now, the asteroids fall, the bullets just go over the top of it. We have our nice cooldown in place. So now let's add our bullet and asteroid collision. So here's my main program right here. Let's add the bullet and asteroid collision. So that's going to happen here. So this is basically, let me add some comments in here just to make this a little more clear what's going on here. So this is like move and draw all bullets. Or this is asteroids. Move and draw all bullets. And then this is remove any asteroids that have been marked for removal. And then this here is going to be the same thing but with bullets. Now, here is where I want to check for bullet and asteroid collisions. And the way we said we were going to do that is we're going to go through every bullet in our bullet list. And we're inside of that, for each bullet, we're going to go through every asteroid. In our asteroid list. Now here, I want to check the distance. So if the distance, and we don't have a distance function right now, so we're going to go ahead and make one real quick. So let's come up here and make a distance function. It checks the distance between 2 points. So def distance. And here I'm going to do x1, y1, x2, y2. So that's going to be the distance between those 2 points. And remember how distance worked. We're going to take the square root of x2 minus x1 squared plus y2 minus y1 squared. So again, this is just Pythagorean theorem. And now we need to return that value that was computed there. And now we have a distance function we can use anywhere we need it. Now let's go back down to where we're using that. Okay, so here's a distance function. So in this case, what are the x and y? So this is going to be bullet x, bullet y, and asteroid x, asteroid.y. So if the distance between those two things ever gets to be less than or equal to the sum of the two sizes, so here, bullet size plus asteroid size. So if the distance between them is ever less than or equal to that, that means that those two things have now collided. I need a dot here, hold on. So that means those two things have collided, so now we need to add those to our to remove list. So both the bullet and the asteroid. All right, so in other words, if they were too close together with the one size of one plus the size of the other was, again, each of these, let me go to the top here. Each of these is going to have a size, and I'm actually going to go and give them a size here, or not the player ship. Okay, I already gave asteroid a size. Actually, I gave them both size, so we're good there. So they both have a size. So essentially what we're saying is and those are sizes over the radius. So if the radius of one plus the radius of another, that's where the two circles would just barely be tangentially touching. That's where they would come together and touch each other. So if the distance between the center points is ever smaller than or equal to where those are touching each other, that means they've collided with each other. And I guess whether you do less than or equal to, it's up to you. But the way I have it less than or equal, that's going to make it so if they're just barely touching then it considers them colliding. You could just do less than, so they have to be closer than that distance, but I'm just going to leave it like that. Now, there is one thing wrong with this code, and the thing wrong with this code right now is that we could have already marked one of them to be removed up here. In other words, we previously could have had a bullet that was already in the bullets to remove list, and now we would add it twice because we're adding that once here, and then we could add it again down here. So in other words, one could be off the screen but colliding with something. We've now put it in the list twice. So one of the things we want to make sure we do is don't add a bullet to the bullets to remove list if it's already in the list. So what I'm going to do is I'm going to say if that bullet is not in the bullets to remove list, then we append it. So in other words, don't add it to the to remove list if it's already in the list. So only add it if it's not in the list. And we're going to do the same thing with the asteroids. So if the asteroid is not in there, to do that. All right, let's run that. And now let's notice we have a couple there. And 3 of them got through. And so now we have our code. It is actually tracking that pretty well. Here, let me move the window so you can see all of it. Let me see if I can. Just barely survived that one. And if we're not happy with how fast the bullets move or how fast the asteroids move, or we want to add some other color variation to the asteroids, make the bullets kind of look a little more interesting, we can certainly add those kinds of things to this. So for example, if I wanted to, let's add a variation to the size of the asteroids. So rather than setting the size to 30, I could say random.randint. Let's do 20 to 35. And now we get a different range of sizes of asteroids. Smaller ones are going to be a little harder to shoot. And I don't know if I'm going to make it here. Nope, I lost there. If we're not happy with the firing rate, we can make it faster, we can make it slower. But now we're on the way to know how to do that collision between objects. And again, let's look at that code real quick. The part that's doing the collision, we went through every bullet, we went through every asteroid, and we said, hey, if the distance between that bullet that I'm on and that asteroid is less than the sum of their radiuses, that means they have to be colliding. So then I add it to the to remove list, both the bullet and the asteroid, but only if it's already not in the to remove list, because we don't want to have it in the to remove list twice. And then once I'm done with that, then I go through the to remove list and I remove them from the main list of bullets, main list of asteroids, to get rid of them. Okay, so that will be it for today. Let me switch back over here just for a second, back to the presentation. So we wrote that code. And that's it. So work on Lab 7. For those 3 or 4 of you who are actually watching the videos, you now have most of what you need to do Lab 7. And remember, there are bonus points for that lab. So if you wanted to add sound and wanted to switch out the asteroids for a graphic and wanted to add the little people running around at the bottom, you can get quite a few bonus points for that. And also, as a reminder, be ready for the programming portion of the final exam. Everybody did the paper portion, and some people did well, some people not so much. It really shows that the number of views on the videos is the number of people who did well on the exam was about equal to the number of views on the video and the number of people who've been doing the labs. So make sure you understand that code that I just went through today. make sure you understand how to have things checked for collision like that. And doing Lab 7 not only will give you the points for Lab 7, and doing the bonus for Lab 7 will help you make up for some lost points, but also it's going to help you with this programming part of the final exam to know this stuff. So that's it for today. Stay safe. And next time I'll decide if I'm going to do another lecture or not. But this is the last week of lectures. The stuff that you learned in this class, for those of you who worked at it and did the work and watched the lectures and did the labs, it's going to end up being really useful for you for the future. The concepts that you see in the checking the distance between things to do collision, managing lists of things, object-oriented programming, extremely important. But when you play a AAA title game, I don't know, like Fallout, New Vegas, or Skyrim, or I don't know what new games have come out recently that are AAA titles. But when you're playing one of those games, the concepts of what we're doing in here with lists and variables and objects and moving things and rendering things and checking collision between things, all of that, it shows up time and time again, no matter whether it's a 2D game like we were making today or whether it's something complex. More complex in a 3D environment with a kind of procedurally generated world. Programming is programming no matter what it is that you're coding. So the techniques that we learned this semester, you're going to be using next semester and the semesters after that and the years after that. And eventually, hopefully, if you make it through the degree, you're going to be working for a AAA title game studio, working on the next version of some AAA title franchise or something completely new, and you're going to be writing code that's using these ideas. So this stuff is not designed for me to be mean and to make you do things and to make you fail the class. And I told you from day one, you need to put some energy and effort into it and do the work. Some of you have done that, and I'm very proud of you. Some of you still have a ways to go. And I know it's been rough with the classes being remote, but you still need to work at that. So be ready for the programming part of the final exam. I want to see everybody do well on that, and everybody get all the points for that. There may be a chance for some bonus points there too. So if you didn't do as well in the paper part as you wanted to, be ready for the programming part. And be ready to write code. Be ready to have that code work and do stuff. But do the labs. All right, that's it. Stay safe, wear a mask. COVID numbers are high, so just be very careful. And I'll see you soon.